Implicit differentiation. We know that from the single variable calculus, there's implicit differentiation. That if there's function, if the y depends on x, is determined by the function f(x) of y equals 0, then we differentiate both sides by x to find the dy over dx, the derivative of y in terms of x. That is, we take the derivative both sides by x, then to find dy over dx. In the procedure, we regard y as a function of x. Use the same trick, we can find the derivative for several variable functions implicitly. The first one is like the implicit differentiation in single variable. If the function f(x) of y equals 0, we need to find dy over dx. What is this? We take the derivative both sides. Take the derivative to x both sides. Then f(x) plus fy times dy over dx equals 0. That is, dy over dx equals negative f(x) over fy, provided if fy non-zero. If there are three variables, that is f(x), y, z equals 0, determine a function z equals z x y. Then how to find? Partial z, partial x, and partial z, partial y. Use the same trick. We take the partial derivative both sides by x. We have f(x) plus fz times partial z, partial x. Use the chain rule. Use chain rule here. Then we have partial z, partial x equals negative f(x) over fz. Here, fz should be non-zero. And take the both sides by take the derivative both sides by y. We have y fy plus fz partial z, partial y equals 0. Then we got partial z, partial y equals negative fy over fz. That's the implicit differentiation for multiple variable functions. Now let's look for some examples. The first example, that is x cubed plus y cubed minus 6xy equals 0. Then find dy over dx. We take both sides by we we just need to, from the formula, we just need to find fy fx. That fx is 3x squared minus 6y, and fy equals 3y squared minus 6x. So dy over dx, that is negative fx over fy. So that is negative 3x squared minus 6y over 3y squared minus 6x. That's the dy over dx. Okay, the second example. If x cubed plus y squared minus 1 equals 0, we need to find dy over dx and the second derivative, d squared y over dx squared. First, we have fx, that is 3x squared, and fy is 2y. So dy over dx, that is negative fx over fy, that is negative 3x squared minus over 2y. And the second derivative, we can take the derivative for x and take the derivative in terms of x for the first derivative. So d squared y over dx squared, that is d dx as negative 3x squared over 2y. We use the quotient rule, that is negative as 2y squared, and the derivative for the denominator, that is 6x times 2y minus 2, the derivative of the denominator, that is 2 dy over dx times 3x squared, that is negative 4y squared, that's 12xy minus 2 dy over dx is the we got the dy dx before, so we just inside the dy over dx minus 2 dy dx is negative 3x squared over 2y, and then times 3x squared. That is 4y squared as negative 12xy, and plus, that's 2, so that is ln x4 over 2y. We multiply both numerator and denominator by 2y, that is negative 8y cubed. That is 24xy squared plus ln x4. That's the second derivative, and the first two examples are just has one independent variables. And the third example, that is x squared plus y squared plus z squared minus 4z equals 0. We need to find partial square z partial x squared, the second derivative. And because it's only to take care about the x. So fx, that is 2x. Fz, that is 2z minus 4. So the first derivative, partial z, partial x, that is negative fx over fz. So that is 2x over, that's negative 2z minus 4. We can write as 2x over 4 minus 2z. And the second derivative, we just take the derivative again for x. That is partial z. That's partial z, partial x. That's partial x, sorry. So that is partial x. That's 2x over 4 minus 2z. Use the quotient rule. That's 4 minus 2z squared. And that is 2 in the denominator. That's 2 times 4 minus 2z. Minus as negative 2 partial z. Partial z, partial x times 2x. That is 8 minus 4z. That's negative times negative, that's positive. That's plus 4x times partial z, partial x. That's 4 minus 2z squared. And we insert the partial z, partial x. That's x minus 4z plus 4x. The partial z, partial x, that is 2x over 4 minus 2z. That's the denominator as 4 minus 2z squared. Then we multiply both numerator and denominator by 4 minus 2z. So that is 4 minus 2z cubed. That is 2 times 4 minus 2z squared. That is 2 times and plus 8x squared. That's the solution. Actually, there's the trick is the same as single variable calculus here. Okay, that's the implicit differentiation.